Is it a fresh afternoon or a sleepy afternoon? All right, everyone's still fresh for a few more talks. And then there we have lightning talks, which is what we call flash talks written there. All right, I urge anyone who is interested in giving a talk to put your name down there. Especially, I had a lot of people coming and telling me, oh, I couldn't submit my talk in time. All right? Oh, you know what? I like this talk. I think I can talk about this too. Put up your talks there. The good part about that is, it's your time to stand here and get your 5 minutes in the limelight. All right? We are recording all these talks. So if you actually want to promote yourself or try yourself out as a speaker, it's a fantastic way to go to. The great part, there is no selection. It's in first come, first serve basis. I think there are already 7 talks there. We have slots for 3 more. So the next 3 people to put up their lightning talks there will get to speak on stage. Right? We are also going to conduct open spaces after the lunch, after the tea break. Now, open spaces is going to be an interesting concept. How many of you all are already aware of what open spaces are? Awesome. So there are very, very few people. So it's a super interesting concept. You want to participate in that. Note, I did not use the word listen. You have to participate. With that, let's start for post-lunch session. And Karthik here has helped me ensure that the jinx of what I had started off with, like entrepreneurs and failed entrepreneurs and people who've been there, done that. Here's one of our young entrepreneurs again. He has recently started his own company.
Yeah.
Which company is that? If you look at your handband, do you see a company's name there? Credero. That's how you get it. So, Karthik here's coming to speak about, he's been speaking earlier at GopherCon. He's also been, quite active on the free open source movement. And today, he's going to give a talk about Gopher in Infraland. So, Karthik, over to you.
Yeah.
We have to clap.
Thank you. Okay. Good afternoon, guys. Good afternoon. I'm very sure that this is not how you would want to imagine your afternoon in Goa on a weekend. Okay? But fortunately or unfortunately, we're here. So let's make the best out of it. And this talk is for those now who already know that Go exists and some best parts of Go, but still trying to find those, really strong reasons on why to use Go, right? If you belong to that group, this talk would be very much relevant to you. But even if otherwise, the Go gurus in Goa, so it would be still bad to have a Go refresher and sort of revisit all the things you know. I'm still sure that you could find a few more things which could still be very much relevant to you too. So yeah, let's start with Gopher in Infraland. Okay, now it must be evident that looking at the list of big projects in Go, that Go has got the attention of the DevOps and the infrastructure community and the enterprises. Now, the list of projects, that's using Go to build infrastructure and DevOps tools is ever increasing. And Go is actually on the path to become a dominant leader in the space. And there must be some solid reason, a lot of reasons on why multiple enterprises, the open source community, and organizations across the world want to use Go to build infrastructure and DevOps tools. So here's my effort to throw some light upon why and how and why does it make sense to use Go. Now, okay. Let's start warming up with visiting a few of the popular projects. The list is just long, but yeah, some of them, like Docker, you have Kubernetes, you have container orchestrated Kubernetes, and minions and object storage, a database. So you have a wide variety of infrastructure tools that have used Go. Okay. The reason why Go has becoming predominantly popular in this space is because Go helps you to solve a lot of the challenges which one face while you build or while they build a large scale software, like a software with large teams or a software with mammoth size. And Go helps you, to solve various challenges which one faces through this journey. And let's see what are these challenges and how Go helps to solve them. So this is to solidify your confidence in Go, to use Go to build your infrastructure projects too. Okay. This is something an infrastructure project or a DevOps project most care about, right? These are the tools which other organizations would use to solve their infrastructure woes, right? You wouldn't want people to just be stuck at just setting up this tool, which could help you solve other issues of yours or other issues of your infrastructure, right? So which means that the tools which are used to solve your infrastructure problems should definitely be easy to set up, easy to install, deploy, and get it up and running. So if one is a PhD to, to set up an object storage, to set up a database, to set up a container orchestrator, like it actually not helping you much. Right. How does Go solve that problem? Like, it's a really big concern for infrastructure tools or DevOps tools. So Go builds and compiles and gives you a binary, and which all of us know that a binary is easy to deploy, right? And which means that to automate the process of setting up VMs, to deploying your binaries, to have containers which could just pull in a binary and run. And all of these processes would be really simple. And the barrier to get started, what's the barrier? If you're using, the barrier would be to just download the binary. You need an internet connection, and possibly in a Unix environment, you need to do chmod. That's the barrier to get started. Absolutely, that's it. For example, look at Minio, right? Minio is an Amazon S3's open source alternative. All you got to do, is that download the binary, chmod, run it, port number 9000. What you have is an Amazon S3 running right out of your box. Okay, and similar with any other tools which are built using Go, right? Even CockroachDB, like such a complex system, such a complex distributed database system, and but the ease with which one can get it up and running, it's pretty amazing. And this actually is, goes a long way in ensuring a greater and wider adoption of the tool, compared to making it really tough and complex for people to get started. A binary also means, right, freezing the version of the software, that infrastructure tool, is super simple. Because consider a scripting language now. You need to also freeze all its dependencies, all the dependency package versions too. But now, a specific version of your software is just a binary. You need to just archive the binary. Right. Here is yet another fact or yet another concern for every infrastructure project. That is the woes associated with the build system. Now, a poor build system, would lead you to have bloated binaries, which means that you need to ship bigger binaries. And a poor build system complicates testing. It discourages testing. Why? Because making any modification, refactoring, it's painful. It's time-consuming. So which means that it makes a developer's life hard to make changes to the code, test it, ship, and goes against the philosophy of continuous deployment. So this talk is not about dwelling into the specifics of why Go's build system is robust, But this is to tell you and sell you that these are a set of things which Go makes it easy for you. And these are the reasons behind its wider adoption in infrastructure projects. Now, some of the highlights are that it eliminates the circular dependencies in your code. And the standard libraries itself have been designed in a way that their dependencies are minimal, which means that when you use the standard library, you get a relatively smaller binary, if it wouldn't have been concerned during the design of the standard libraries. Now, again, a faster and a better and a smaller build helps you to refactor the code and iterate through the code more number of times and ship it more and more number of times. Okay, now we all have seen how to write hello world in Python, in Java, in C, and Go, right? When you look at hello world, it's very hard to sort of come to a judgment that which one of these programming languages are easier to get started. You know, it's a very subjective argument, right? But I guess there would be much value to the argument if you go and ask this question: how easy it is to master the language? Now, how easy it is to plunge into a complex project and understand the source code, and how easy to read a project which has been built by thousands or hundreds of developers, which has been there for around with a large code base and a large number of developers on it. How easy it is to plunge in between and get going faster. So that barrier to master the language in Go is very less compared to other languages like Java. And we'll see some of the reasons why it is comparatively easier to master Go than other languages. Right, you have very less keywords, and the syntax is pretty easy. And the control flow too, like even consider the case of error handling. You know, the whole paradigm of having the throw, catch, rise, this sort of exception handling where the control flow is hard to follow up. But by design, Go makes it really simple. And being simple, or simplicity has been one of their guiding principles of design. And this is really critical for infrastructure projects, since these code base can grow really big. And even if you look at the open source community, if the enterprises wish to open source these projects, and now you have the whole community coming in to contribute, it becomes much more important that the barrier to get started is minimal. Right. This always happens when you build a big project, or if it's a large-scale project, that in the process of chasing a mouse, you ignore the bomb underneath you, right? The processes involved in writing a stable software, and it's much elaborate. It's much cumbersome compared to how Go allows you to, or facilitates you to write a stable piece of code. And here are the reasons why. If you're writing tests, any statically typed language makes it more simpler, right? And does it mean that writing unit tests or writing stable piece of software in any other scripting language is hard? No, that's not what I'm trying to imply. So there is a difference between why an aeroplane is tested much more rigorously than an automobile. Right? So similarly, infrastructure projects are the tools which other enterprises or companies use to store their data, and to manage their infrastructure. So definitely the standard for its reliability are extremely high. So which makes all of these facilities and aspects which Go provides really an exciting prospect for enterprises to choose Go in building infrastructure tools. So, bugs are caught at the compile time, which reduces your risk in runtime. Doesn't mean that if you get it wrong, it doesn't crash in runtime. But test facilities comes bundled with language. which means that you need not have to go to a framework X, Y, and Z to write your tests. It comes bundled right within the language. So this sort of fosters the community, to feel very much native about writing tests. The culture around writing tests is much more prevalent in Go when compared to other programming communities. It's because that from the day of inception, Go has been very, very clear about having these tools as part of the language. Now, here are a couple more things, which makes your lives simpler in your attempt to write a stable software. Okay, this is performance is something which any infrastructure tool, like may it be a object store, may it be a database, any of such tools would be really concerned about. And how does Go make writing a performant piece of code simple? Okay, so here is 2.0 of concurrency, right? The race for being possessive about processor time, it's not new. Back in days when threads were not there, processors had to shuffle the CPU time, to obtain their stint at processing. But then came threads, wherein it sort of solved a lot of hard work involved in the context switch. It made a lot of these processes much more lighter. But Go takes this paradigm to another level, wherein the Go runtime abstracts the usage of threads by using Go routines. Now, consider Go routines like, imagine it to be a lightweight thread, wherein your chances of getting a shot at CPU time is much, much more higher because you are processing with a better concurrency. But Go's runtime is the one which manages, the Go scheduler and the runtime managers on how these different Go routines take a dig at the CPU. Right. Memory management is definitely another critical aspect when you build a technology, right? I was at, so previously I was working in this startup called Minio. So Minio was building, again, as was discussed earlier, an open source alternative to Amazon S3. So we had a strong reason with respect to why we chose Go, even in terms of its memory management. Because unlike a database, an object storage has more throughput, which means that it needs to do more I/O and stuff more objects into memory and send it via network. So we saw that when we compared all other facilities which Go provides, its memory management was equally good. And this was for a lot of reasons. We can have just a talk around why Go's memory management is better and what makes, or what are the facilities inside Go makes this simpler. So again, Go's garbage collector is much more sophisticated than what Java provides, and which means that the overhead associated with the garbage collection, which controls the automatic memory management, is way better and cheaper. Right. In development teams, we very seldom find that developers are performance focused, which means that developers hardly understand, usually they hardly even try to care about the performance implication of their code. So consider a scenario like, how much does developers usually understand that this particular commit or this set of code changes, what was its performance impact? Did it consume 2x more CPU? Did it help me optimize the memory by 20%? So it's difficult to understand the implications on resource consumption and performance because of the tooling around associated with these other languages. But again, Go provides these tools bundled, with everything else it provides in its tool set. And which means that you get profiler, the benchmarking facilities, all of these are built in within the language, which encourages and fosters the culture of being performance-oriented and understanding the performance implication of your code changes. And this culture goes a long, long way in ensuring that the development teams and bigger development teams can also be focused and understand the performance implications of their code changes. Right. Building a complex software is not just about engineering. Now, it also has its management worries. Right. So one of the biggest concern is managing code complexity. So as the project gets bigger and bigger, how do you ensure that the code still makes sense for human beings? So Go by design has always been focused on ensuring that managing the complexity of the code when the code base grows bigger has to be made simpler. So Go has simplicity by design. So for example, I could sort of quote two such specific design decisions. One could be on saying no to the typed hierarchy, which means the subclassing or inheriting in a particular class. Those facilities do not exist in Go. And Go believes in having consistent behavior, and which in subclassing is hard to ensure. So, and also this simplifies, understanding the code, the readability of the code too. And this is what Go believes in. And right. So in large development teams, I've seen project managers or the architects struggle really hard to enforce a consistent workflow within the teams. To have, for example, look at these questions. Which convention and tools one need to use? What should be the style for your code? Or how do I go about structuring my project? And it becomes really difficult to have a consistent methodologies and policies across large teams. And Go sort of makes it simple by being opinionated, which means that Go enforces some practice to you and enforces you to follow certain ways of doing things versus having the flexibility of achieving something in large number of ways. So there can be an argument to say that you would love flexibility versus being opinionated, but when the team gets bigger, when the code base becomes larger, and the woes associated with having a consistent and right set of practices becomes much, much more simpler. Right. So what is the conclusion? The biggest reason why I believe that Go is now emerging as a first-class citizen or the dominant choice of language for building infrastructure tool is because Go is minimal. So you can argue to say that, hey, hello world in Python is much more simpler than writing in Go. But doing things in a minimalistic fashion means it's got the right mixture of everything that's necessary. So yeah, haven't used Go? Tonight's the night. We're in Goa. This probably is a good chance to do that. And if you still are not convinced to use Go for building large-scale infrastructure scalable projects, then this probably is the best thing to do. GitHub 2 offers status updates now. So not just Facebook. So you can just go there and update it to be complicated. And yeah, thank you. Thank you for being here, and thank you for your valuable time.